This video will cover the final part of the section 4-5 notes, which involves converting quadratic equations from standard form into vertex form. This is the main application other than solving quadratic equations for the completing the square skill, which we have worked on rather extensively over the first week and a half of the semester here. It is also part of, although not the part that will be tested, part of the major skill of completing the square, which is one of our 10 major skills for second semester Algebra 2. So just as a quick reminder, a quadratic in standard form is written in the form ax squared plus bx plus c, and vertex form, or the same quadratic, would be a times x minus h quantity squared plus k. Now remember that each of these formats has their advantages. Standard form is what we're used to seeing. C actually tells us the y-intercept of the function if we were attempting to graph it. And this a value is the same a in both formats. That tells us whether the function opens up or down, as well as whether it is stretched vertically or compressed vertically. We haven't really spent a lot of time on that yet, but when we get into polynomials we will. Vertex form has the advantage of being able to identify the h value and the k value. H and k give you the location of the vertex of the parabola and make it very easy to graph. So, if we are going to convert f of x, which in this example is x squared plus 12x plus 23, to vertex form, that is a very similar process to completing the square. What we do is we look at the first two terms, x squared plus 23x, and we ask ourselves, does the a value equal 1? There is no number in front of x squared, so the answer to that question is yes, which means that we are ready to insert our blanks. So we are going to insert a blank inside the parentheses after 12x, and we're going to insert a blank after 23. Now the major difference between this and completing the square is that we are not allowed, when we convert, to work with both sides of the equation. So in completing the square we would add here and add to the other side of the equation. We can't do that now, so instead we add on the inside, and then to keep the equation balanced we subtract that same amount from the outside. The next line will look very similar to what we had in the previous lesson. That is x blank squared. Other than that, the process is the same that we carried out when we were solving quadratics by completing the square. We take 12, we divide by 2. That would be 6. 6 goes in this bottom blank. We then take that 6 and we square that value to get the number that goes in this top blank. Now, since we added 36 to the inside of the parentheses, we have unbalanced this equation because we've added 36. So in order to keep it balanced, we then have to subtract 36. Because if I add 36 and then subtract 36, I have not changed the value of the function. The final step then in this process is to combine these two numbers. 23 minus 36 would be negative 13. So my vertex form, this is done now. This is the advantage of this, is that it's a shorter process than converting the square. Our vertex form is f of x equals the quantity x plus 6 squared minus 13. And we can use that to identify h and k and give the vertex and the axis of symmetry. So the problems we're actually going to have to be able to perform with this skill are very multifaceted. They're reaching back into the skills that we covered earlier in Chapter 4 when we were graphing quadratics. So let's take a look at one of those. I don't know that we'll do all 4 examples that were in the notes in this video because that would be a fairly long video, and let's face it, you guys are not watching these videos if they're more than about 6 or 7 minutes long total. So the problem reads, convert the following quadratic function to vertex form. That's step 1. Then identify the vertex and the axis of symmetry. That's going to involve h and k. And finally, graph the function and identify the zeros of the function. So the graphing part is going to require us to use our calculator to generate a table of values. Now, if you're good, you can create the table of values without a calculator, but I'm not expecting that of you, as any problem you do in Algebra 2 on in the real world, you will have access to either a calculator or a computer that will do that work for you. So, we group the first two terms, and we ask ourselves, does A equal 1? There is no number in front of x squared, so the answer to that question is yes, and we are ready to insert our blanks. So we insert a blank on the inside, and we subtract from the outside, just like we did on the previous example. We prep for completing the square by starting to write the next step, and then we carry out that conversion. We take the b value, -10, and we divide by 2. That would be -5. We then take that value and we square it to get +25. Then we copy that value into the other blank, because if I add 25, I then have to subtract 25 to keep the equation balanced. Final step is to do 21 minus 25, which would be -4. So my vertex form, my first answer for this 5-answer problem, is f of x equals quantity x minus 5 squared minus 4. Now I need to use that in order to find the vertex and the axis of symmetry. I need to keep in mind that vertex form is y, or f of x, equals a times x minus h squared plus k, which means if I look at this equation, I can identify h and k. The h value is the number inside the parentheses, except the h value is always opposite of what is shown. So in this equation that says x minus 5, that means the h value is the opposite of that, +5. The k value, on the other hand, is always exactly what is shown in the equation. So the k value, since this says -4 on the outside, would be -4. Now the reason that we need h and k is because our vertex is located at the point hk. So in this case that would be 5, -4. And the axis of symmetry is the line x equals h, which in this case would be the line x equals 5. So that's 2 more of our 5 answers. We fill in those blanks using h and k. Now the final step in this process is to graph this. That is easier said than done. If we have the calculator, then it's not a big deal. What we do is we use the table function. So on the calculator, you're going to look for the table button. When you get the table button, it is going to prompt you to enter the function. You are going to enter this entire right side of this equation. So you are going to enter x minus 5 quantity squared minus 4. Be very careful. Make sure you're using subtraction symbols, not negative signs for these two signs. Then it will ask you, well, where do you want to start the table? You want to start the table 2 less than h. So in this case, that would be 5 minus 2, or 3. When you hit enter a couple times, you'll scroll down to OK, hit enter. It will print the table of values for your quadratic starting at 3. And you can scroll up and down in that list as much as you need to get a good picture on your coordinate plane. Now, we already know what those values are if we're familiar with quadratics, because there is a pattern to the way that quadratics are graphed. If a is equal to 1, then when we move out 1 unit from the vertex, we move up 1 unit. And when we move out a second unit from the vertex, we move up another 3. Out 1, up 5. So there is a pattern to the way that we graph quadratics. But anyway, you get this table of values, and that gives you these 5 points. So go to your coordinate plane and graph those 5 points. 3, 0, 4, -3, 5, -4, 6, negative 3, and 7, 0. Now if we went out a step further, we would discover 2 more points, and if we went out 1 more, we would be at 12, roughly here. So when we draw our curve, it should come in, go through those points, and then head back out again. And I got a little bit too far to the left here, but it's not that important. So once we have the graph, that's the fourth part of the problem. It says graph the function. The final step is to identify the zeros. Well, we've discussed in class several times how zeros, there are several words to describe that, and one of those words is x-intercepts. So the reason we're graphing before we identify the zeros is we are looking for the x-intercepts. We are looking to see where that function crosses the x-axis. That would be here at the point x equals 3, and here at the point x equals 7. So we would say the zeros are x equals 3 and x equals 7. Now you could also write the points 3, 0 and 7, 0. That would be fully acceptable. If you say 3 and 0, I would probably let that go, but that's not really ideal. So there's one good example. Let's do another one. Alright, so once again we're going to grab those first 2 terms. We're going to ask ourselves, does a equal 1? The answer is yes. So we simply adjust our function to include our blanks. So x squared plus 14x plus something plus 49 minus something. Our next line as well, we can start, will be x something squared. So we take the 14, we divide by 2. When we divide by 2, we get plus 7 for that blank. We take that 7 and we square it. That is 49. Then we copy, which is 49. 49 minus 49 is 0. And you know, I wrote an equal sign here out of habit. There really shouldn't be one there, so let's get rid of that. Instead, we would either leave this blank because this does equal 0, or we would put plus 0. And given what we're going to do with this information, I'm going to go ahead and write plus 0. So our vertex form for this function, g of x, is the quantity x plus 7 squared plus 0. From that, we need to identify our h value and our k value. So once again, the h comes from the number inside the parentheses. It is always the opposite of what is written there. It says plus 7, so h is negative 7. K is always the number after the parentheses. That is 0. So our vertex, which is located at hk, would be negative 7, 0. Our axis of symmetry, which is the line x equals h, would be x equals negative 7. Then we need to graph this. So on our calculators that we have in our classroom, we would use the table button to access the table function. We would type the right side of the equation into there. After it says y equals, we type in that binomial squared plus 0. And we should start that table at negative 9. And again, that is because we want to do h minus 2. Okay? So it's 2 less than negative 7. Now again, I've said this in class multiple times. If you start your table at the wrong place, all that's going to happen, it's still going to generate the same table. You're just going to be at a place where there are either huge numbers or tiny numbers. Just scroll up or down until you have points that are on the coordinate plane. So if we are graphing these points starting at negative 9, our table function should return the values negative 9, 4, negative 8, 1, negative 7, 0, negative 6, 1, and negative 5, 4. So we are going to graph those points. It's worth noting that if we go out one more unit on each side, we would be at y equals 9. So negative 10, 9 and negative 4, 9 would also be points on this parabola. So we draw our curve through those points. That takes care of the graph. And then we look for x-intercepts, because that's what the zeros are. They are x-intercepts. Well, in this case, there is only one x-intercept at x equals negative 7. So the value negative 7 is a 0 of this function. Let's take a look at one that does not have a nice a value. So here is h of x. We're going to grab those two terms. We ask ourselves, does a equal 1? The answer is no. So what we do is we have to make it equal 1. Now when we completed the square, we accomplished that by dividing by a. But we're not allowed to divide, because in order to divide, we have to be able to access both sides of the equation. So instead, we have to rearrange the function and trick it into thinking we divided by factoring out our a value of 2. So when we do that, we have 2 times x squared minus 12x plus 64. Now we're only factoring the 2 out of the parentheses, so 64 is unaffected. And when we factor out a 2, what we do is we divide these two terms by 2. 2x squared divided by 2 is x squared. Negative 24x divided by 2 is negative 12. Now a is equal to 1, and we're ready to insert our blanks. Now this part is a little bit trickier as well, with an a value that is not equal to 1. The inside blank is still just a blank. But the outside blank needs to have that a value attached to it. We're going to multiply whatever number we insert in this blank by 2. So we haven't added, say, 15 here. We've added 15 times 2, or 30. So when we add this much, we have to make sure to subtract the same amount. So if we have an a value here, that has to be the same value in front of this blank to keep the equation balanced. Okay, our next line as well will look slightly different, because that 2 is not going to go away. It will still be sitting in front of the parentheses. But really, that's the only difference. The rest of this process is exactly the same. We take negative 12, we divide by 2, which would be negative 6. Then we take that value and we square it to get 36, which means this is 36. This part is slightly more complicated, because instead of just having to add or subtract two numbers, we need to multiply first and then add or subtract. So this would be 64 minus 72, which would be negative 8. So our vertex form is h of x equals 2 times x minus 6 squared minus 8. We still pull our h and k values exactly the same way. So h would be positive 6 and k would be negative 8. We still state the vertex exactly the same way. We still state the axis of symmetry exactly the same way. So we list hk for the vertex and x equals h for the axis of symmetry. Now we need to graph it so that we can state the x-intercepts. So we go to our table function. Don't forget, when you type it into the table function, to include that 2. It is 100% necessary. We are going to start our table function 2 less than h, which would be at 4. And when we do that, we should generate the table 4, 5, 6, 7, 8 for the x values. And that should give us 4, that shouldn't be an 8, that should be a 0. 4, 0, 5, negative 6, 6, negative 8, 7, negative 6, and 8, 0. 4, 0, 5, negative 6, 6, negative 8, 7, negative 6, and 8, 0. If we went out one more on each side, we would be at 10. So 3, 10, and 9, 10 are on this parabola as well. Draw your curve. Pen is not behaving. There we go. Nope, lost it again. Come on, pen. There you go. Good job, little guy. And identify your x-intercepts, which are located at those 2 points. This one is x equals 4, and this one is x equals 8. So our x-intercepts would be 4 and 8. There's only one more example, so we might as well just go ahead and do it in this video. We're going to group the first 2 terms and ask ourselves, does A equal 1? The answer is yes. So we're going to insert our blanks. Notice how I'm speeding up, because by the 4th example, you should all be speeding up. We're adding on the inside and subtracting from the outside. The next line, we're going to start with our blank quantity squared. 8 divided by 2 is 4, so this should be a plus 4. Square that would be 16. 19 minus 16 is 3. So J of x should be x plus 4 quantity squared plus 3. This means that h is negative 4 and k is 3. It's really k from there and h from here. I need to clean that up because I'm going to be saving these notes and printing them on Google Classroom. So give me just a second. Let me clean that up a little bit. Alright, so h is coming from here, and k is coming from there. Okay. That means the vertex is located at the point negative 4, 3. If my pen will let me write that. Again, that is hk. The axis of symmetry is the line x equals h. That would be x equals negative 4. Then we're going to use our table function starting at negative 6. Again, that's because of h minus 2 is what we're trying to start at. So xy, we're looking at negative 6, negative 5, negative 4, negative 3, and negative 2. And this one has kind of an interesting graph. We go in here and we graph these points, negative 6, 7, negative 5, 4, negative 4, 3, negative 3, 4, and negative 2, 7. And when we graph that, this is the correct graph, but it has an interesting problem. It doesn't touch the x-axis. So it doesn't have any x-intercepts. That just means there are no real zeros. This function actually does still have solutions. It does still have solutions, zeros, well, not x-intercepts, but they're just not real numbers. That does it for this video. I hope this helps you on your homework.